What we're looking at today is a repeated measures ANOVA. Now, if you remember back to previous lectures or courses that you might have taken, you may recall that when participants are tested repeatedly and we're wanting to compare them on just two levels of an independent variable, what we're using are a dependent samples t-test. When participants are tested repeatedly and we're looking at one independent variable and they're being tested on more than two levels of an independent variable, well, we are in ANOVA territory. You may recall that you did a repeated measures ANOVA. Repeated measures ANOVA is also called a within groups or within subjects ANOVA. The repeated measures ANOVA permits us to explore data that's related to questions that can be quite complex. But at its most basic level, a repeated measures ANOVA comprises multiple measurements of a variable for each participant in the study. And those multiple measurements need to be greater than 2, so 3 or more measurements repeatedly done on a particular participant. A repeated measures ANOVA can be used when there are more than 2 levels of an independent variable. For example, suppose you wish to determine whether a new medication reduces the symptoms of anxiety, and the new medication is given to a sample of participants with anxiety. Anxiety symptoms are recorded once a fortnight for a period of 3 months. What's your dependent variable? Well, your dependent variable is some measure of anxiety symptoms. And you can see that we're measuring these anxiety symptoms repeatedly, more than 2 times. So this is an example where our repeated measures ANOVA may be used. Consider another example. Suppose a teacher's interested in learning whether the scores on 4 examinations for her class change significantly over the course of the year. Again, the dependent variable are the scores on those examinations. Because there's more than 2, we know, and it's the same participant, then we know that we're using a repeated measures ANOVA. Now, the assumptions of a repeated measures ANOVA are similar to a dependent samples t-test, with one important exception. Usually the variable that you're measuring is interval or ratio level data. There's also a random selection of participants. The dependent variable is normally distributed in the population at each level of the independent variable, and there's also independence of observations across individuals. In addition, the repeated measures ANOVA has the important assumption of sphericity. This in essence refers to homogeneity of variance in the difference scores between the pairs of treatment levels. Now I'll explain sphericity in more detail later, and I assure you it's the concept is not as hard as it is to actually say the word. But basically sphericity is an important concept that underlies repeated measures with more than 2 levels. But first, let's go to an example. Okay, so we have 10 celebrities in the Dancing with the Stars competition. And they've all danced salsa, hip hop, waltz, or cha-cha. So the IV, the independent variable, is the type of dance. And there are 4 levels, which are salsa, hip hop, cha-cha, and waltz. The dependent variable is the rating of the judges for that particular dance, and it's out of a possible score of 100. So we have 10 celebrities. They've all danced salsa, hip hop, waltz, and cha-cha, and the scores you can see are the scores that a judge has given them out of 100 for that particular dance. So celebrity 1 scored 50 out of 100 for their salsa, 72 in the cha-cha, 60 in hip hop, and 70 in waltz. All these scores for celebrity 1 are different. So there's some variability in their scores across all the dancers for this particular celebrity. For salsa, they scored quite a bit lower than they did for waltz and cha-cha. So there's variability within celebrity 1 of 102.7. This is a variance within the person. What the repeated measures ANOVA attempts to ask is, of this variability that we can see, how much variance is due to their own innate ability to dance, and how much variability is due to the type of dance that they've been judged on. So if you have a look at celebrity 6, for example, their variability is quite small. It's only 33 in terms of the dances that they did. Their scores from the judges also because they've got a small variance, seem to be quite consistent. So it looks like the type of dance did not really affect their overall score for each dance. Their scores varied from 59 to 71. So the type of dance did not have too much of an effect. So we have variability within each participant, and are asking the question how much is due to variability in the type of dance, in other words, the experimental manipulation, and how much is due to the natural ability to dance. You also have the mean within each condition. The mean score for all the celebrities for salsa was 48.1 out of a possible 100. The mean score for cha-cha was 72.3, hip-hop 59.2 and waltz 68.5. These are the means that a repeated measures ANOVA is comparing. But what's going on behind the scenes? You can see that all the scores vary from each other. If the scores are quite closely knit together, then you get a small total variability. If the scores are quite different from each other, then you get quite a large variability, and the total variability score will be higher. Regardless of the amount of variance, an ANOVA divides into two separate independent parts. Each part's associated with a different source. If you look again at the data that's been collected, you can see that the variability in the scores is associated with different celebrities. You can see this in the rows. There's a lot of variability for celebrity 1 to celebrity 10 for salsa. For example, the mean salsa score was 48.1, but celebrity 7 scored 40 in the dance, and celebrity 2 scored 55. So there's variability between each celebrity. This is known as variability between subjects, and our attention in the repeated measures ANOVA is not really focused here. Now let's focus on the variability within subjects. That is, let's look at the variability within each of the celebrities. For example, if you have a look at celebrity 3, this celebrity scored 44 in salsa, 56 in hip-hop, 68 in waltz, 70 in cha-cha. Their total scores varied from 44 to 70, so they had a total difference of 26. And their total variability was 145, so it's clear they scored quite differently across the dances. If you look at celebrity 6, their variability is quite small. Their scores for the judges was quite consistent and ranged from 59 to 71, so the difference was only 12 across the 4 dances. So you can see that the type of dance did not have much effect. So where does this variability within celebrity across the different dances come from? Clearly, the type of dance affects the score. This is captured in the total variability that's explained by the dance. But it also looks like this doesn't account for all the variability. The variability that remains is unexplained variability. The question that we're asking is, do the celebrity scores change across the different types of dances? In the null hypothesis, we're indicating that there will be no difference in the means across each of the dances. The alternative hypothesis says that at least one mean is different from the other. Notice the subscripts that we use are I and J to denote the means. The null hypothesis indicates that there's no change across the 4 dances. The alternative hypothesis indicates that a significant difference exists between at least 2 of the dances. To answer these questions, I need to go to SPSS. I'll use this example in more detail and highlight some of the important assumptions and interpretation of SPSS output in the future videos. Thank you.